Vitamin B3, better known as niacin, may not have the flashiest reputation among vitamins, but it is the metabolic backbone of your entire body's energy economy. Without it, your cells would be running on fumes or not running at all. Niacin's greatest claim to fame is its role as the essential precursor to NAD, nicotinamide adenine dinucleotide, and NADP, its phosphate form, two coenzymes that are absolutely critical for converting the food you eat into usable cellular energy. That's not a metaphor, it's biochemical fact. If you're alive and upright, niacin is in the engine room, making it happen. Every bite of food, whether it's a spoonful of oats, a chunk of salmon, or a peanut butter sandwich, contains carbohydrates, fats, and proteins. But these macronutrients don't deliver energy directly. First, they need to be broken down into their building blocks: glucose from carbs, amino acids from proteins, and fatty acids from fats. That's where niacin enters the scene, stepping into every single major metabolic pathway to help usher these molecules through the energy-making process. NAD is the ultimate cellular workhorse. In glycolysis, the process by which glucose is broken down, NAD is used to shuttle electrons around like a courier on a mission. It helps pull energy out of glucose and transport it into the mitochondria, where the real magic happens. There, in the Krebs cycle and the electron transport chain, NAD becomes the primary electron carrier, delivering high-energy electrons to generate ADP, the actual energy currency of your cells. Without enough NAD, this process grinds to a halt. It's a bit like trying to run a factory with no electricity. The parts are all there, but nothing's moving. And ADP, on the other hand, plays a vital role in biosynthesis and antioxidant defense. It's especially important in the pentose phosphate pathway, which doesn't directly generate ADP but supports the production of fatty acids and nucleotides, building blocks of cell membranes and DNA. And ADP also helps regenerate reduced glutathione, one of the most important antioxidant systems in the body. In this way, niacin doesn't just help create energy, it also helps protect your cells from the damaging byproducts of that energy production. It's like having an energy generator with its own built-in air filter to keep things clean and running smoothly. What's particularly fascinating is how niacin-powered NAD adapts to your body's needs. During times of fasting or intense exercise, the body shifts from burning glucose to burning fat for energy. NAD doesn't skip a beat. It's still there, facilitating the beta-oxidation of fatty acids and ensuring that ADP production doesn't dip. When protein is broken down for energy, which hopefully isn't often, unless you're in a starvation state, NAD is again front and center in the deamination and conversion processes. No matter what fuel you're burning, sugar, fat, or protein, niacin is making sure that fuel gets converted into power. On top of that, NAD acts as a signaling molecule in its own right. It's involved in activating sirtuins, a family of proteins linked to cellular repair, aging, inflammation control, and metabolic health. These aren't just nice-to-have perks, they're essential for long-term resilience. The more efficiently your cells make and recycle NAD, the better equipped they are to respond to stress, repair damage, and keep functioning with age. Niacin's role in energy metabolism isn't just about staying awake or feeling physically energized, it's about cellular vitality. A niacin-deficient cell is one that's losing its grip on energy management, repair systems, and survival. That's why even mild deficiencies can manifest as fatigue, brain fog, irritability, and muscle weakness, symptoms that often get chalked up to stress or aging but may have nutritional roots. Thankfully, getting enough niacin is relatively easy if you eat a balanced diet. Poultry, fish, liver, peanuts, and whole grains are all rich in niacin or its amino acid precursor, tryptophan. The body can convert tryptophan into niacin when needed, although it takes about 60 milligrams of tryptophan to produce just 1 milligram of niacin, so it's not a very efficient backup plan. Still, this metabolic link highlights how interconnected nutrients are in supporting health. Unlike some vitamins that play niche roles, niacin is everywhere. Every organ, every tissue, every single cell in your body demands a steady supply of NAD and NADP to function. When you zoom out, it becomes clear that vitamin B3 isn't just one piece of the puzzle, it's the glue holding the entire metabolic jigsaw together. Without it, life quite literally cannot be sustained. So, the next time you feel a surge of energy after a good meal or a brisk walk, remember, niacin is right there at the molecular level, flipping the metabolic switches and keeping your cells in motion. It may not come with flashy headlines, but in the world of energy metabolism, niacin is the quiet power behind everything that moves.